In this video, I'm going to start talking about complex numbers in algebra. Sometimes this is referred to imaginary numbers. Now, this is my personal favorite topic in algebra, so I hope that comes across in these videos, and it's always kind of a treat to me that in our class, this comes after word problems, which can be very taxing. But I do really enjoy this topic, and I hope that I can try to explain why I enjoy such a topic. So, to start off with and explain what we're going to learn is I first want to solve x squared equals -1. Okay, now if I'm going to solve something like this, I would take the square root of both sides. So I have x squared equals plus or minus the square root of -1. Okay, so x must equal plus or minus the square root of -1. Well, what is the square root of -1 equal to? The square root of 1 is just 1. Square root of 1 is just 1. But we need a number times itself that equals -1. And see, -1 times -1 would be +1. So what would equal -1? It doesn't really seem like there is a number that could possibly do this, but we often run into problems where it would be really helpful if we had a number that this worked. And so what I hope you will give me the benefit of the doubt is we're going to say that the square root of -1 just equals the letter lowercase I. And this is going to stand for an imaginary number, some number outside the real numbers, okay? So the formula that you have to know for this section is that I is going to be defined as the square root of -1, and everything else is going to work as a consequence of this. Okay, so let's get a feeling for how this might work and if this even works at all, okay? So for my first example, I want to talk about the square root of -49. Now this can kind of go back to a previous section with square roots, and you can break that up as -1 times 49. And we know that 49 is a perfect square. It's 7, but I can break this up as -1 times 49. And since 49 is a perfect square, I can turn that into a 7. And I'm claiming that we can write square root of -1 as an I. So I say that the answer is 7i. And most likely your calculator would say it's an error. It doesn't work. But for right now, I just want to play and see if this works, okay? Now, we are going to write complex numbers in a particular way. We're going to say that a plus bi is how we can write it, and a is going to be the real part, and b is the complex part. Now, let me do a couple examples and show you exactly what I mean by that. So an example is very similar to our previous one, and that's the square root of -64, which I can break up as -1 times 64, okay? And that would be the square root of -1 times the square root of 64. Well, I have memorized that 8 times 8 is 64, so I can say 8i, okay? Now, there is no real part to this, okay? This is pure imaginary, all right? So in this case, a would equal 0 and b would equal 8 to get a plus bi to equal, I guess you could say 0 plus 8i, okay? This is a way of saying that this is a pure imaginary number. There's no real part to this. All right, let's look at another example, and hopefully some of the confusion will clear up. So now I have 6 times the square root of -81. Well, for now, the 6 is just going to kind of hang out. So you have -1 times 81. I have memorized that 9 times 9 is 81, so that's a perfect square. So I can bring 6 times 9i there, okay? Now, 6 times 9 is 54, So I can say, oh, well, this is going to be 54i. Okay, and again, this is a purely imaginary number. This is pure imaginary. All right, so a would equal 0 and b would equal 54 for a plus bi. 0 plus 54i. Okay, now how does that work for normal numbers that you know, like the number 2? How does 2 work? Well, 2 could be written as 2 plus 0i. This is pure real. All right. So far, that probably seems a little confusing, but this is how we're going to be able to break this up. And so everything we've learned before will still apply, but we can start moving forward and start talking about numbers that are outside of the real numbers. So I want to talk about how we could add and subtract complex numbers. Now again, I'm not multiplying, I just put parentheses to signify which one was which number. But we're just going to add these, not multiply these. So I have -1 plus -1, that'd be -2. And I have -5 plus -1, that'd be -6i. And so for adding them, I basically just treated I like it was just any old variable, like it was x or something. There's nothing left to be done. You can just add them. So that's not too bad. If you're adding complex numbers, you're just really adding like terms like you would if it was a variable. -1 minus -1, okay, well that's going to be 0, that's fine. -5 minus -1i, so that'd be plus, so that'd be -4i. And so that would be the final answer, 0 minus 4i, that's in the a plus bi format, just like this is. This is also in the a plus bi format. It's pure imaginary. This had a real part. This is its real part, and this is its. I don't want to say. I'm going to say imaginary. Imaginary part. Okay. So multiplying these numbers. It is essentially the exact same as we did before with variables, except when you multiply I against itself. So I want to show you this example. So -10i times -4 would be positive 40i. So that's really the same as if it was an x. And then -10 times -4i. So it's -10i. So this would be positive 40i squared. And that is the different part. This is the different part because I is defined as the square root of 1. So I squared is -1. So this right there is -1. Okay. So this is 40i minus 40. And we can write that as -40 plus 40i. So it's in that a plus bi format. All right. Let's see if we can finish this example before the end of the video. So I have the square root of -1 here. I can actually just rewrite that as I, since that is how it is defined. And let's see what happens. 4 times -4 is -16 plus 4i plus 4i minus I squared. Checking my terms here. Yep, that's right. So I have -16 plus ai minus -1, so plus 1. So -15 plus 8i as my final answer. And that is in that a plus bi format. Okay, well, I'll see you in the next video, but that's how we can multiply them.